Hello everyone, hope you all are well. Now in this video we will start with a new topic, that is second law of thermodynamics. Basically in the first law of thermodynamics drawback, we have studied that according to that law 100% heat is converted into work. This is according to first law of thermodynamics. But in the drawbacks of first law of thermodynamics, we have studied that practically this thing is not possible, that 100% heat will convert into work. So second law of thermodynamics will explain this concept that 100% heat is not converted into work, rather than some amount of heat is lost in the environment during the process. This is basically second law of thermodynamics, means the whole amount of 100% heat will not convert into work. Some amount of heat gets lost in the environment during the reaction. Before understanding the second law of thermodynamics in detail, we have to understand two types of processes basically, that is spontaneous process and non-spontaneous process. Spontaneous processes are those processes which takes place by itself, or on initiation it takes place by itself. Means कुछ reactions spontaneous ऐसियां ਹੁੰਦੀਆਂ ਨੇ जिन्हां ਨੂੰ ਆਪਾਂ ਨੂੰ initiate करना पैंदा है, but after initiation they will take place by their own. But there are some reactions which do not need ignition to start the reaction. These reactions are spontaneous reaction. Let us consider one example. If we want a downhill movement of water, suppose the water is moving from upside to downside. There is no need to apply a pump. We have to do nothing for it. This will happen naturally. We have not to initiate this reaction. So this type of reactions are spontaneous reaction which have no urge to initiate the reaction. Second example, evaporation of water. If we keep the vessel open and the water molecules present inside it will get evaporated by itself. And there are some reactions which has the urge to initiate the reaction. For example, if we want to convert this calcium carbonate into calcium oxide and CO2, we have to heat this calcium carbonate. If we do not heat it, then it will not convert into calcium oxide and CO2. For one more example, when we burn a paper, it will burn by itself, but initially we have to burn the paper. If we initially burn the paper, then that paper will completely burn by itself. So these all reactions are called spontaneous reactions. Now there are certain reactions which are non-spontaneous. For example, uphill movement of water. Movement of water from downside to upside. This will not take place by its own. So this is a non-spontaneous reaction. Spontaneous reactions are those reactions which takes place by its own, or are to initiate and then takes place by its own, that is spontaneous. And non-spontaneous reactions, the reactions which do not take place by its own, that are called non-spontaneous reaction. One more example is in this non-spontaneous reaction. Suppose we have a cup of tea. That cup of tea is hot. After some time, it will become cool down. Means heat is transferred from hotter to colder region. Our environment is colder than the cup of tea. So heat from the cup of tea transfer to the environment. But if we want reverse, that cup of tea is cold and our environment is hot, can it be transfer? The heat from the cup of tea will transfer to the environment, as the cup of tea has cold, means heat will not travel from cold body to hot body. This is a non-spontaneous reaction. So this is the basic difference between spontaneous and non-spontaneous reactions. Now the question arises, why some processes are spontaneous and some processes are non-spontaneous? So these are based on two driving forces, which is tendency for minimum energy. Minimum energy and tendency for maximum randomness. For maximum randomness. So, there are two driving forces which will explain that why some processes are spontaneous and some are non-spontaneous. Tendency for minimum energy. Minimum energy means maximum stability. If any electron has minimum energy in its ground state, then it will become more stable. If it will get more energy, then it will become unstable. So to become more stable, there should be minimum energy. For this case, minimum energy means your energy should be very, very low, means delta H should be negative. Minimum energy means your enthalpy should be low, that is negative. But there are certain reactions in chemistry which have delta H is equals to positive. For example, I have already told one example. If we provide heat to it, then it will convert it into CO and CO2. This reaction involves delta H positive because here heat is absorbed, means amount of energy is absorbed, energy supplied. So here delta H is positive. This is also a spontaneous reaction, but initially we are saying that for a reaction to be spontaneous, delta H should be negative. But there are certain reactions in which delta H is positive, still a reaction is spontaneous. There are certain reactions in which delta H is negative, but still it is spontaneous reaction. For example, when there is the expansion in the vacuum, then this reaction is called spontaneous. So from this we conclude that only enthalpy is not the factor. So the only enthalpy is not the factor to decide that whether the reaction is spontaneous or the reaction is non-spontaneous. Now come to second driving force, that is tendency for maximum randomness. Randomness means, suppose initially the molecules are very, very closely packed. Very, very closely packed. In this container, it will become. So this is the randomness. In this case, the randomness is more. So, tendency for maximum randomness. If the randomness is maximum, then the reaction is spontaneous. Now, suppose the evaporation of water. Initially, water is in liquid state. We already know that in liquid state, but the molecules are closely packed. In solids, molecules are very much closely packed, that there is no intercellular space between them. Molecules are very closely packed. This is about solids. Now we see this liquids. There is a small intercellular spaces. This is about liquids. Molecules are closely packed, but less closely than solid. Now if we talk about gas, there are molecules very far apart. So for evaporation of water, the water initially present in liquid form, so its molecules are very close, but when it gets boiled, it will convert into vapor form, means gaseous form. Then its molecules are far apart. If they are far apart, then they are free to move, so randomness will be more. So this is an example of tendency of maximum randomness. So on the basis of this whole concept, that there are two driving force, tendency of minimum energy and tendency of maximum randomness. On the basis of these two concepts, it is concluded that the spontaneity of the reaction doesn't depend only on enthalpy, or it doesn't depend only on randomness. It will depend on two factors, both enthalpy as well as randomness. We call randomness as entropy also. This is all about this spontaneous and non-spontaneous process. Now come to the statements of second law of thermodynamics. Now, these are some statements of second law of thermodynamics. First one is all the spontaneous processes are irreversible. For example, if we talk about the downhill movement of water, water is moving downside from the mountains. But if we want to reverse this reaction, we have to apply some external agency, mean motor, pump, we have to apply. Similarly, we are talking about heat is transferred from hotter body to colder body. But if we want it reverse, then we have to boil it or provide heat to it. So this is an external agency. So on the basis of this, all spontaneous processes are irreversible. Second, without the help of external agency, a spontaneous process cannot be reversed. This is already explained in the first definition. Suppose if we want to make the cold tea again hot tea, then we have to provide heat, means boil the tea. Boiling is an external agency. So without external agency, spontaneous process will not get reversed. The complete conversion of heat into work is impossible. Complete conversion of heat into work is impossible without leaving some effect. Means बिना कोई effect छड़े complete heat nu work ਦੇ ਵਿੱਚ convert करना, it's quite impossible. This is a statement of second law of thermodynamics that complete heat will not convert into work. All spontaneous processes are accompanied by net increase in entropy. All the spontaneous processes will take place. Then there will be the net increase of entropy. What is entropy? Basically, entropy is degree of randomness. जितनी ज़्यादा randomness, उतनी ज़्यादा entropy. So, all spontaneous processes are accompanied by net increase in entropy. There is an increase in entropy. That is, all spontaneous process has total energy should be positive. Increase in entropy means there is some positive value. Last definition, the entropy of universe is continuously increasing. If we talk about that, there is the net increase in entropy, then in case of universe, the entropy is continuously increasing. If we sum up first and second law of thermodynamics, then it will say energy of the universe is constant, but the entropy of the universe is continuously increasing. If we combine first and second law of thermodynamics, we will get the definition. The energy of the universe is constant, but the entropy of the universe continuously increasing. This is all about the basic about the second law of thermodynamics. That's all for today. Thank you and have a nice day.